Welcome to this special lesson. This lesson is going to be kind of related to the one to the transducers. Okay, so this lesson I'm going to talk about is on relays. So this is a picture of a relay. It's actually quite small. Yeah, so this is a relay, this small little blue box there. Yeah. So that's the relay model that we have in our lab. Yeah. So let me explain to you first of all what the pins are. So this pin, these two pins here are the pins that will power up the electromagnetic coil. Yeah. So this is the power pin to the relay. Yeah. So once you connect up this, the electromagnetic coils inside will power up, they'll energize, and they would switch the throw from the switch. Yeah. So what about this? This is your common. These two pins are your common pins. These are your normally closed pins. Okay, so just a reminder, NC stands for normally closed. Okay, and these two pins are your normally open. Okay, so normally open. So if you don't do anything, you don't power up, you don't energize the relay, the common and the normally closed are hooked up. Okay, so if you don't do anything, the common and the normally closed are connected. All right, but the moment you energize the coil, let's say you energize the coil, the electromagnetic field is produced to energize the coil. What happens is that the switch just now was normally closed, common to normally closed. Now the switch switches to the normally open. Okay, so there is a switching between the normally closed and the normally open, depending on whether you energize or don't energize the electromagnetic coils in the relay. Okay, so how it works is that if let's say you do not have any current going into your electromagnetic coil, so the current actually comes here, goes through the common, then it goes into the normally closed, and then it comes back down to earth and completes the circuit. Okay, so this is how it would normally work. Yeah, but then let's say you connect up the power switch, and then what happens is that right now the electromagnetic field is going to turn the switch from normally closed, it's going to flick it to the normally open. And now that you've powered this up, the current goes here, 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 and goes through the normally open and back down here. Okay. Now, you'll be wondering, so what does this thing do? Well, it works in exactly the same thing. So if I don't connect up anything here, it's fine. It's cool. Nothing happens. This gives me the option of a second simultaneous output. So if let's say I were to connect LEDs here, all right, so this one, the LED is switch on off depending on whether you energize the electromagnetic coil. Yeah, but if let's say I wanted an LED plus a buzzer to work in tandem, I can hook up the second common NCNO pair, and then what happens is that when the electromagnetic coil turns on or off, energized or not energized, now I have LED and buzzer turning on or off at the same time. Okay, so one more time, if let's say I don't do anything, I don't connect anything here, that's fine. This will still work. But if let's say I do connect up a buzzer here, let's say I do connect up a buzzer here, The moment it is energized, both this switch will flick to normally open, and this will flick to normally open. This one will come here, and there is another route for this fella to come here. Okay, so I hope you get it. Stay tuned, don't go, because I'm going to attach a video where I hooked up a circuit demonstrating the use of this relay. Okay, so that's going to come up right now. Okay, so this is a video about the relay. So this is the relay that I was telling you about, and this is the circuit that I hooked up. So let me get this. Okay, so as I was saying, this is your power source to power up the relay. Yeah, so you got to power up the relay here, and what I did was I added a switch here. Yeah, so I added a switch here. Okay, forgive the amateurish recording. And then this is your common. Remember, common needs to be connected. All common pins need to be connected. And what I've done is that I've put a LED at the normally closed position and one LED in the normally open position. So always remember, you got to put a current limiting resistor when you're using LEDs. Okay, so what happens is that now the normally closed is lit up. Okay, the normally closed, because it is normally closed. So what happens is that there's current flowing through the common into the normally closed and back to ground. That's why it is lit up. Now what happens when I close this switch here? When I close this switch, the normally open, now the normally open is going to get turned on. Okay, so when I close this switch, I'm going to power up the relay, and once the relay is powered up, there's the Singapore double throw switch is going to switch over to the normally open and close this fella now. So this is what it looks like. Yeah, so I'm going to power up the relay now. So all the electromagnetic coils are going to attract the normally open switch to close. Yeah, and now we see that the other LEDs have lit up. Okay, so now I'm not pressing, the coil is not magnetized, it's not powered up, so current just flows into the normally closed. But when I close the switch, what's happened is that the electromagnetic coil is now going to be powered up, and it flicks the switch over to the normally open to close, and now current comes into the common and into the normally open, which is now closed, and back. Okay, so technically I did not have to hook up anything. I didn't need to use the other pair for the normally open, normally close. It would work perfectly fine if I just had the top circuit, yeah, because there is still a common normally closed, normally open, it's fine. But this is how you hook it up, so that you can have the option of maybe here you have a LED and here you have a motor or buzzer or whatever it is. Yeah, so you can have two pairs now. But again, if you just want to use the first normally closed, first normally open, that's fine as well. That will work perfectly fine. Okay.